Welcome to class. We would like to start with the demonstration of today's class. What we see here on the screen is the screen of an air quality monitor. And first I would like to introduce what is being shown here. First of all, the temperature in this room, which is live, 23 degrees of C, seems a little bit on the warmer side. The relative humidity, which we're very much aware of, but that doesn't mean 39 on the drier side today. And then we have the air quality index. We'll show what goes into this calculation a little later. Then we have the PM10 in micrograms per cubic meter of air. And then we have the PM2.5 and the PM1, all micrograms per cubic meter. So the total PM10 is the value which accumulates all of them. So if you look at the PM2.5, right now 7 stands for out of 11, that the majority of those particles are actually smaller than 2.5 by aerodynamic diameter. The main concern is, of course, the PM1 and below, and we have about a quarter or fifth of these particles in that smaller range right now. The air quality value, or the word is given right at the bottom, is it good or not? You will start seeing it changing as we proceed with this demonstration. So without no more ado, I'm going to lit a candle here, and then can trigger a little bit of the increase in the PM matter. And I want you guys to think about it, what's happening here. So the candle is burning. See, the sensor is right on the side. There's a blue color. So, and no much of a particular matter. You could. But the way that you don't break up, you're already tightening all the couple. All right. It's probably not. Thank you. So here's the side of it right here. So here, sensor part is right here. So what happens is, what are the combustion products, guys? What are the combustion products? If it's complete combustion, we learned that in the stoichiometry. CO2 and water. So nothing is problematic there, right? The minute we have incomplete combustion, we're going to start to see PM, CO, and other products. And then we're going to see that in no time. When I'm going to extinguish this candle, what's going to happen now? And look at the screen now. So what happened to air quality? We're way over 200, 300, right? We're 500 there, right? The PM1s, look at how big those are. So PM1s are dropping down. The total was, I think, the highest 3,000. Did you see that? I think it was over 3,000. And of course, it equilibrates stuff. What's happening now? The clean air is replacing it, right? The bloom is diluting in time, so there's a diffusion, right? The particles are diffusing. To me, I can smell it already. So there are some of particles in my nostrils right now. That smell, when you smell it, it means you already are in contact with these particles. You don't see them, but you are in contact already. It takes a little bit of a time to equilibrate all the way back to the room. In fact, if I take this away from here, this should do it actually faster, right? Because to equilibrate. So this is how we can monitor particular matter in the indoor air. I have this type of meter at home. So when we had these Canadian fires over the summer, my PM meter was always over 50, over 60. And that showed that, the outside air quality was compromised. So what you want to do in this type of situation is close your windows and doors and put your air purifier to a maximum speed. And your meter will reflect that in no time. You'll see the particular matter dropping very fast down to 0 or 5 or very low background values. So we smoke quite a bit, right? So it seems it takes quite a bit to equilibrate back to the normal. Okay, questions, comments? Yes.
Question. So is PM2.5, PM1, the sum of them typically are equal to PM10?
Yeah, PM is like, think about it like a big box, all of them. And then PM2.5 and 1 are inside a box. So if you look 146 or whatever it's dropping to, 124 out of those would be lower than 2.5. So it's always changing. It's hard to see. So 105 and 113, the large particles are only very little there. There's a lot of fine particles still in the air right now. 95, and then look how big PM1 is, 81. So these particles, what they right now here are super fine, and they are diluting slowly. You see that? It's a live reading. So now you see it turn green. You see, everybody saw the color turn green. That means it dropped below 50. So that's a sort of like acceptable limit. We'll cover that a little bit too.
I've got another question. Is there
Sure.
time averaging in the equation for?
No, it depends on the room and the ventilation of a particular room, how many rotations of the air this particular room will have, right? So what happens is right now the bloom I released is diffusing in this room, and that's why the concentration is dropping of those PM matters. These are the concentrations, micrograms per cubic meter. So it really depends on room. When you have very good air circulation, these numbers will go down in no time, right? So here I can still smell. I don't know if you can, but I can smell the candle. Do you? You can. Okay. You're too far. That's why. But that's what it is. More questions? Everything looks nice and green. It should stabilize. So this is on healthy level we consider. Although they are concerning, 20, 25. But they're healthy. They're not considered, bad necessarily that you have to be overly worried about it. Once again, these were particular matters, right? So not necessarily the physical particle may not be the source of toxicity, but rather than also some PAHs or polyaromatic hydrocarbons, which are attached to those tiny particles. That could be. So the particle matter becomes a carrier. Think about like a carrier, like plane carries a bomb, right? So that's exactly in a comparison. The particle carries the bad stuff too into your deep lungs. Surprisingly, a high PM1, half of it. If I look at the ratio, total PM10, 34, a little less than half, and 18 the PM1. But it should stabilize. We've warmed up the room. That makes sense because we have 6 students and 2 instructors, so that's 8 people. We are emitting also heat to this room, so we have a little net radiation happening here too. Questions, comments? If not, thank you. Let's thank you, Jerry. Thank you, Jerry. Look at this professional world. This is so professional. Thank you so much. Thank you so much. If you can share the video clip, that will be all what I need. Thank you. And then I would need only HDMI, and everything else is